All right, everybody, welcome to the video here for lesson number 4's homework. So in this lesson, we learned about all the different properties of logarithms. If you are somebody that is struggling with this homework assignment, you could go back and review your notes or just take a look at the lesson summary here on the end of page 21. It kind of shows you the 3 properties that I'll be using here in the homework assignment. So let's take a look at number 1. So number 1 asks us to rewrite this separated group of logarithms. So we want to rewrite them as a single logarithm. So one of the things that we went over is whenever something has a coefficient, we could remake that coefficient back into an exponent. So the first step would be to rewrite each of these common logs with their exponent instead of a coefficient. So I'll rewrite the first one as log of x to the 4th minus log of y to the 1/2 plus log of z to the 3rd. So notice how we're subtracting a sum. Well, with logarithms, subtraction means division. So I'm essentially saying here, I'm going to divide x to the 4th by these two things together. So when I rewrite this as one big logarithm, I'm going to say this is the log of x to the 4th divided by, subtraction means divide, the product of these two individual pieces, so y to the 1/2, z to the 3rd power. That is a perfectly acceptable answer. You could also change y to the 1/2 to the square root of y, but hey, why would you? It's already done for you as a half. So let's look at number 2. It says, using properties of logarithms, show that this expression is the same. So looking at these two separated logarithms, to put them back together, I would multiply. So I'd say log of x squared times x to the 3rd. Also, on the right-hand side of the equation, I have a coefficient, so I can rewrite that as log of x to the 5th power. Now, using our exponent rules, when I multiply x variables, I add their exponents. So I can rewrite this as log of x to the 5th is equal to log of x to the 5th. So I've shown that these are actually, in fact, the same. Number 3 tells us that the ln of 2 is equal to a and the ln of 3 is equal to b. It then asks us to rewrite the ln of 9 over 8. ln, remember, is natural log. Now, since we have natural logs of 2 and natural logs of 3 to represent our variables, I want to rewrite this natural log of 9 over 8 in terms of the numbers 2 and 3. So the first thing I'm going to do is try and figure out how else could I write 9. 9 is really 3 squared. And how else could I write 8? Well, that's really 2 to the 3rd power. So I'm going to rewrite this natural logarithm as 3 squared over 2 to the 3rd power. Then using my logarithm property, since I have division, I'm going to rewrite this as 2 separate logarithms using subtraction. Then I'm going to be able to say, all right, well, each of these exponents is really a coefficient, so I'll say 2 ln of 3 minus 3 ln of 2. Well, since ln of 3 is really b and ln of 2 is really a, I can substitute those. So instead of ln of 3, I'm going to put b, and instead of ln of 2, I'm going to put a. There's my answer. This doesn't come up too often on the Regents exam, but this is an SAT question all day. Number 4 says, explain why we cannot solve this using common bases. 30 cannot have a base of 2, right? I can't make the number 30 with a base 2 without using decimals. So it says rewrite this as a logarithm and use the change of base formula in your calculator to find the value of x. So if I rewrite this as a logarithm, right, I know it's going to be x equals log base 2 of 30. I know that because we have a base, we have an exponent, and we have an answer. All logarithms are in the form of exponent equals log of whatever the base is, evaluating the answer. Then if we actually do this, we can say, all right, so what is log base 2 of 30? New calculator people, just use that log base button in your calculator, and we get an answer here of 4.9. Doesn't say what to round to, so we'll just say 4.9. It's 906 something. If you have an old calculator, you're going to do log of 30 divided by log of 2. You're going to get the same answer, 4.9. You'll see we'll do that a little bit more. Does this answer make sense? So in your calculator, if you do 2 to the 4.9, even though that's a rounded answer, you're going to get approximately a value here. So 2 to the 4.9 is approximately 29.8 something, which is really close to 30. The reason why it's not exactly 30 is 4.9 is a rounded answer. Hopefully this video helped with your homework. If you have to, go back and look over your notes more or rewatch the video and you will be good. See you soon.